All right, so let's start with section 2.4. So we're going to talk about the product and the quotient rule. So the product rule, so if I have two functions multiplied by each other and I take its derivative, it's equal to the derivative of the first function times the original of that function times the function times the derivative of the second function. But just in your book, give it to you in this form and this form, but just to keep things simple, I kind of give you the shorthand notation. So here, if I take a derivative of two functions I multiply, it's derivative of the first times the original plus the original times the derivative. And same for the quotient rule. Here it's the first times its derivative, in this case minus. We'll take a minus and then this minus this. So it's the function f. So I have f over g, so it'll be f prime g minus f g prime divided by g squared. Okay. The proofs of these are in the book. Just because of time reasons, I don't go into them, and also because if I went to the proof sheet, you guys might become a little catatonic of not quite understanding what's going on. So we're going to use the product rule to calculate this, and then we're going to verify our answer by just simplifying, right? Because if I gave you this, you don't need to do the product rule. You just add these two up, you get x to the 6, and then you just go from there. So let's do the product rule just to kind of demonstrate that it works. So in this case, I'm going to make this my f, I'm going to make this my g. And so our product rule of f g prime would equal to f prime g plus f g prime. All right, so f prime, so this derivative here is 8x to the 7th, right? Because I bring down the 8 and then I take one off of this, and then we multiply by g, which would be x to the minus 2. Here, we're going to add to it. We're going to leave f, so that, and then we're going to take this one. Oops. And so here I pull in the minus 2 here. And then it will be x to the minus 3, because minus 2 minus 1 will give me minus 3. So now we just simplify. So this equals 8x to the 5th minus 2x to the 5th. And that actually just simplifies down to 6x to the 5th. Now let's just do this the way you probably should do it, right? Here, if I do this, this is equal to x to the 6th. If I take the derivative of x to the 6th, let's just say this is some function y of x is equal to this. So the derivative of the function of y would just be 6x to the 5th. Okay. And so notice here we get the same. So we can simplify and do it, or we can just go for it and do product rule. Okay. Now, would you use product rule for this? No. But let's do something we'll use product rule for. So let me leave this up for a second, and then we'll switch to it in the next page. I'll lock this up as a GD sheet. And I'm going to open up. All right. So let's do the next one. All right, so let's do this one real quick. All right, so here's use the product rule here. And so I'm going to call this my f, and I'm going to call this my g. And so in this case, so f g prime is equal to, that's what we're doing here. This is equal to f and g prime as I defined it. So so that's equal to f prime g plus f g prime. So let's find what f prime is first. Well, f prime is, if I take the derivative of this, the 4 hops down and I have a t. to the third power, and then plus a constant, which is plus 0. G prime is just equal to e to the t, because that doesn't change. And so let's go ahead and we'll use this. So here I take one derivative, or take another derivative, and we'll just plug it in here. So here I'm going to have 4t cubed e to the t plus 4t t to the fourth plus 3. Well, e to the t is still just e to the t. And so here's our solution. Your book may or may not factor out the e to the t, and then you'll have t to the fourth plus 4t cubed plus 3. It might do the extra step. All right, so give it a try and go ahead and do this. Go ahead and try this one real quick. See if you can get an answer, and then I'll go through it. So give that one a try before I give you the answer. And as you do that, I'm going to show you how to type derivatives into Wolfram Alpha, so you can check your work. All right, so this was t to the all right. Can you scroll up a bit? Yeah, I can scroll up a bit. There you go. And once one or two people have a solution to what example 3 is, we'll go forward. I want you to give it a try once. And if you don't know what to do, go ahead and ask me in chat, or just say it over. But I do want you to try at least one of these before I move on. What do you do with the sine of x? Well, okay, so let me. So let's just for kicks say call this f and call this g. All right, so here f is equal to x squared, f prime is equal to 2x, g is equal to sine of x. Well, the derivative of sine of x is cosine x, right? And then you just put it all together. Just put the answer, just post the answer. Just post the answer. Okay, so we have, we've got a bunch of people. All right, so let's just do this. All right, so here, I want to do f prime, or f g prime is equal to f prime g plus f g prime. And so here we have, I mean, if it helps to write out this, by all means do that. And so here, we'll have 2x sine of x plus x squared cosine x, and that's our solution. Yeah, that is our solution. Now, if I wanted to type this into Wolfram Alpha to check it, how would I do that? Well, let me show you how. You literally just type it in, kind of as you see it here. You put d/dt, then you're going to put a comma or parentheses, and then you can type in x squared sine of x, close the parentheses, and then let it crunch through. You did not do what I wanted you to do. Why is it not taking my derivative? Oh, that's why. Do you put x's here? No. They should say. What did I have? Are my notes wrong? Yes, my notes are horribly wrong. If I took this with respect to t, I'd get nothing. This should be dx. Hi. This should not be t. This should be, it should say d dx, because we have x's here. So that's my fault. So, but now, if I type in that, if I have d dx, it should give me my derivative. And here we go. And here they pull out the x, right? Here they pull out the x, but here if we put the x back in, we'll have 2 sine of x cosine of x squared. And so this is how you type it in. And you can do this for our other one. Let's go ahead and do our other one real quick. What was that? This one was t. Let's just go back to t. I'm going to just show you how to type this in twice. That way you know what to do. And you put in parentheses t to the 4th plus 3 e to the t. And then if you crunch it through, it gives us the answer in the more simplified form, which we did here. Okay. All right, so let's do the last one, or the next one, and then we'll work on quotient for a second. Oh, no, we're already to quotient rule. All right, so here we're going to do quotient rule. And so here we're going to just say everything up top is F, everything on the bottom is G, and I did rewrite this to be the correct letter this time. And so what do we need here? So we need F, so F is going to equal to y plus 3. F prime is equal to 1, right? Because if I took the derivative of this, this becomes a 1, this becomes nothing. G is equal to e to the y. If that looked like a y, not a 4. And then G prime is equal to e to the y because it's its own derivative. So what do we want to do? Let's look at our little cheat sheet. We want to do f prime g minus g prime f over g squared. So let's type that in. So f over g prime is equal to f prime g minus f g prime over g squared. Just plug in what we have here. So f prime is 1 times e to the y minus the quantity of y plus 3 e to the y all over e to the y squared. We simplify this out. I'll have e to the y minus y e to the y. The minus filters in here, so it'll be minus 3 e to the y all over e to the y squared. And then here we can do one more step to make our life slightly easier. You can get rid of one of the e to the y. So this should just be 1 minus y minus 3 all over e to the y. Okay. I like the pause and then let's try first. We have time today to do such things. And so I do like doing it when we have time. And so let me just show you. All right, and then here, let me show you how to type this in one last time. And here we have y plus 3 divided by e to the y. Be very careful that when you look at it, this looks like the answer we have. Now, does this look exactly like ours? No, right? It doesn't here. And I wanted to go over this real quick. So this is what I typed in. This is what I calculated, and this is what I typed in. Are they the same? Well, the answer is yes. All we have to do to get to this answer is we simplify these two. So here I'll get minus 2 minus y over e to the y. Pull out a negative 1, so this will be negative y plus 2 e to the y. And then we just move the e to the y up top. And so here I have minus e to the minus y. And that's the same as we get from Wolfram Alpha. So if your answers don't immediately look like the one you can calculate in a calculator or that, don't worry too much. Just do a little bit of math and see if they're the same. They're equivalent. All right, so let's do the last 2 pages. We might even end a little bit early today. I know, shocking of shocking, right? Hold on, let me go back to. Yes, this is y plus 2. If I take out the negative, let me make that a little clearer. And take out a negative, this becomes positive, this becomes positive. I just changed the order, that way it matches the calculator. Can we go over some homework problems? Yeah, that'd be fine. All right, so what do I let me leave this up for 1 second. Actually, let me export this real quick. That way I can get rid of it. Yep, it would say bye-bye. Leave this up for 1 more second. You should be able to see what you need right as I export. Maybe. I don't remember where the export button is. All right. Oh, why does e to the y squared equal e to the y? Here I'm taking away one of the e to the y's. Here I could have filtered this out. I could have had e to the y, 1 minus y minus 3 over e to the y squared. Here I canceled out one of the e to the y's to get to this step. Okay. All right. All right, so let's go ahead and zoom on in. All right, so let's go ahead and have you guys try this one. Go ahead and try this one. So set this equal to f, set this equal to g. And then remember your quotient rule of f over g prime is equal to f prime g minus f g prime all over g squared. Okay. So go ahead and do that. And we're going to do this one. We're going to do this one twice. Oh, we can't do this one twice. You don't have the tools to use it twice. Next time I'll be able to do it twice. Once you have chain rule, I'll show you how to do this twice so you can avoid doing quotient rule. But go ahead and give this one a try. And then once you have an answer, go ahead and put that into chat. I'm going to mute you for 1 second. We got one solution. Let's get like 2 before I move forward. How is that not working? Anyone else get a solution? I'm going to do the first part of it as you guys finish it. So F prime, G, and G prime. So F here is minus 2 plus 1. This derivative here is just minus 2e to the x. Plus 1 goes away. This doesn't actually change, and the constant remains constant. Here, g is equal to x squared plus 5. Or 3x squared plus 5x. And then our derivative, so 2 times 3 would be 6x. Be 6x. This becomes that, and then plus 5. All right, so now let's just plug it in. Let's go ahead and plug it in. So here, I'll have minus 2e to the x times 3x squared plus 5x minus f minus 2e to the x plus 1 times 6x plus 5 all over 3x squared plus 5x squared. Okay, and let's just simplify the top a little bit. Notice everywhere I'm going to have an e to an x. So I'm going to, nope, not everywhere. So let's not do that. So let's just distribute this in. So this would be minus 6 x squared e to the x plus minus 10 x e to the x minus a minus, or let me just do minus and keep this all together as one. So let's do this first. So this times this will give me minus 2 or minus 12x e to the x. And then this times this will give me minus 10 e to the x. This time this gives me plus 6x plus 5. And then we'll distribute the negative sign. So this becomes positive, positive, negative, negative. Okay. And notice here, I can simplify the top just a little bit more if I wanted to. I make this negative 6x squared e to the x. These two come together just to be plus 2x e to the x. And then this is just, and then one of these will be plus 10 e to the x minus 6x minus 5 all over x squared plus 5. Oops, I had this in the wrong spot. 5x squared. I had it in the wrong spot. So yes, it was in the wrong spot. All right. So doesn't x have to be, should it be minus 1? No. So if I take x minus, if I have x to the 1 power, let's see if I can say this. X to the 1 power. If I move that down, this becomes 1. It'll be x of 1 minus 1, which is just 0. And anything to 0 power is 1, so it just ends up being 1. And so here this 5x just becomes that. Okay. So it just drops to a constant. Okay. Any questions on this? Is this kind of big and ugly? Yeah, it is. If we type into Wolfram Alpha, do we get something close to that? Hold on. Well, not so big. Yeah, here. All they did is pull out a 2x, but they have the minus 6x, the x to the x to the 5, minus 6x minus 5, and then here they pulled out an x out of here. So when you pull that out, it becomes squared. And so it's the same. So here, this is the same. All right, so now we're going to do both at once. Fun. We're going to have fun under the sun. So here, we're going to use both the product rule and the quotient rule to calculate this. And so now we can do them in tandem. So here, this is going to be my f, and this is going to be my g. And so here, f over g prime, once again, is equal to f prime g minus f g prime all over, hold on, yes, g squared. Well, here, f is equal to t cubed e to the t. So f prime, we're going to have to use product rule. And so if we use product rule here, we're going to keep this one. We're going to take a derivative of this one. So it'll be 3t squared e to the t plus, and then we're going to keep this one constant and take the derivative of this one. So 3e to the t. Oops, that should be a t, not a 3. So here, if I take a derivative here, in order to do this, it's product rule. And if we do the product rule, we get this. And g is equal to 2t plus 1. So g prime is equal to just 2, because this becomes 1, this becomes 0. And we just plug it in. And so I always suggest you do this. So when we plug that in, we're going to have 3t squared plus e to the t plus t cubed e to the t times g, which in this case is 2t plus 1, minus f, which would be t cubed e to the t, times g prime, which is just 2, all over e to the plus 2 plus 1 squared. Okay. Now, just for the sake of time, we won't simplify this, but you could. So let me let you write that down, and then we'll get to our last page. All right, so let's do the very last page. Hello. Why are you over here? Shushu. Shushu, go back over here. Oops. I'll get to my layers now. Oop. All right. So let's use this to find tangent. Oh, this should be an x again. Sorry. The tangent of x. So here we want to find the derivative of tangent. Well, tangent's equal to, so this is equal to the derivative of cosine of x over, nope. Tangent is sine over cosine of x. There we go. We have sine over cosine of x. And so how would we do this? Well, we'll just take we'll just make this f and we'll make this g. And so here f is equal to sine of x. F prime is equal to cosine of x. G is equal to cosine of x. And g prime is equal to minus sine of x. All right, so let's calculate this. All right, so what do we have here? So we'll go ahead and plug that in. So f over g prime is equal to f prime g minus g, f g prime over g squared. So if we plug that in, here we're going to have cosine of x times g, which is cosine of x. Hold on. I have this completely backwards. F will be sine of x times g is cosine f prime. Hold on. No, I had it okay. See if I can not get lost. F prime cosine of x. I'm going to do this very slowly because apparently I'm getting myself confused. Also cosine of x. And then here we're going to have minus f, which is sine of x, times minus sine of x, all over cosine of x squared. Okay, so this just becomes cosine squared x plus sine squared x all over cosine squared x. But notice here that cosine squared plus sine squared is equal to 1. So I have 1 over cosine squared x. And then if I'm going to rewrite that as secant squared x, I have my solution. Okay. And so once we've done sine and cosine, we could also write this. So cosecant's 1 over sine of x, and then you could use that to calculate this. Secant is 1 over cosine of x. And you can use that to calculate this, and then you can go from here. And so here you can calculate the rest of these using. And so now we have the derivatives for all our trig functions. We have it for sine, cosine, tangent, cosecant, secant, and cotangent.